we want to determine the exact trigonometric function values using reference triangles. So for this example, we want to find the 6 trig function values for 5 pi over 4 radians. So we could convert this to degrees, but I think it's important to learn to work with radians also. So let's leave it in radians, sketch the angle in standard position, form the reference triangle, then determine these 6 trig function values. So the initial side of the angle will be along the positive x-axis. Now we'll rotate counterclockwise 5 pi over 4 radians. Well, half a rotation counterclockwise would be 180 degrees or pi radians, but because our angle is a multiple of pi over 4 radians, it'll be helpful to view pi radians as 4 pi over 4 radians. So if we want to rotate 5 pi over 4 radians, this is telling us to rotate 1 pi over 4 radians more. So we'd rotate to here, and this would be the terminal side of our angle. But also, now that we know we rotated pi over 4 radians past the x-axis, we know the reference angle, or the angle between the terminal side and the x-axis, must be pi over 4 radians. Now we'll sketch a segment from the terminal side of the angle that's perpendicular to the x-axis to form our reference triangle. So this black triangle would be our reference triangle, and because this angle here is pi over 4 radians, or 45 degrees, we have a 45, 45, 90 reference triangle, which means we can label the length of the two legs 1, and the length of the hypotenuse square root 2. But we also have to make sure that we have the correct sign on the two legs of the reference triangle based upon the quadrant of the terminal side of the angle. And since we're in the third quadrant, where the x-coordinate and the y-coordinate would be negative, both legs would have to be -1. And now we can use this reference triangle to determine these 6 trig function values. Now this video does assume that given a right triangle, you can determine these 6 trig function values. If you need to review how to do that, you may want to pause the video here and review these notes. So for the sine of 5 pi over 4 radians, we'll find the ratio of the opposite side to the hypotenuse, which would be -1 divided by square root 2. But a lot of times we are asked to express these values with a rational denominator. So let's go ahead and rationalize the denominator for this value, which means we'd have to multiply by the square root of 2 over the square root of 2. So this would be negative square root 2 over 2. Notice how now the denominator is rational, so we can also express this value as negative square root 2 over 2. For the cosine function value, we'll take the ratio of the adjacent side to the hypotenuse, but notice how it's also -1 over square root 2. So if we rationalize the denominator, it would also be negative square root 2 over 2. Now there are two ways to find the secant of 5 pi over 4 radians. Remember, secant is equal to the reciprocal of cosine, so if the cosine function value was -1 over square root 2, then the secant function value would be negative square root 2 over 1, or just negative square root 2. Or we can use the reference triangle and find the ratio of the hypotenuse to the adjacent side, which would be square root 2 divided by -1, or negative square root 2. There are also two ways to find the cosecant function value, since cosecant is equal to the reciprocal of sine. If the sine function value of 5 pi over 4 radians is equal to -1 over square root 2, then the cosecant function value would be equal to negative square root 2 over 1, or just negative square root 2. Or again, using the reference triangle, we would have the ratio of the hypotenuse to the opposite side, or square root 2 divided by -1, again equal to negative square root 2. And then the tangent of 5 pi over 4 radians will be equal to the ratio of the opposite side to the adjacent side, or -1 divided by -1, which is equal to +1. And then the cotangent function value will be equal to the reciprocal of the tangent function value. Reciprocal of 1 is equal to 1, or again, using the reference triangle, we would have the ratio of the adjacent side to the opposite side. -1 divided by -1, of course, is equal to 1. I hope this example was helpful.